Now let us discuss randomly the AC chapter. See, I have a question here where V V is equal to 200 sine 314t. An equation like this given, and as you know, this V actually means an AC voltage is applied across a 10 ohm resistor. That's how the question is. This AC voltage is applied across a 10 ohm resistance, and they are asking you to find what is the frequency, then peak voltage, then RMS voltage, then RMS current, then power dissipated. All these things you have to find from this particular equation. Now it's very easy, but you have to know the base, what all the terms actually mean. So let me have the actual relation. The AC voltage is given by V equals V0 sine omega t. Now what does each represent? See, this V represents the instantaneous voltage, means the voltage at the time t. Then what does, so V represents, let me rub this part. So V represents instantaneous voltage. What is instantaneous voltage? The voltage at this moment, at the time t. Then what does V0 represent? V0 represents the peak value. Peak value means the maximum value which the voltage can acquire. Then sine omega, sine, what does this sine represent? Sine represents a harmonic function. Harmonic function means the value of V is going to vary periodically as the time progresses. Then what is omega? Omega is the angular velocity, because omega t is actually the angular displacement. So angular velocity multiplied by time gives you the angular displacement. So as the angle changes, the value of instantaneous value of voltage varies from 0 to the peak value. Then again it reaches back to the 0 value. Again it repeats. So that's what this equation represents. Now, similarly, you can have an equation for I also. I is the instantaneous current, which is equal to I0 sine omega t. So term by term meaning is same. I is instantaneous current, current at this moment, that is current when the time is t. I0 is the peak value. Sine shows the harmonic function, that it varies continuously and also periodically. Then omega represents the angular velocity. Now, in the question they have asked you about the peak value. Find the frequency, peak voltage, RMS current, power distance. Now this is, what is this RMS? RMS voltage means root mean square value, root mean square of the voltage. So we have one relation, VRMS is equal to V0 by root 2, which actually represents, see this RMS value physically means when an AC, when you take an AC, as we have discussed, it varies periodically. It moves from the mean position 0 value to maximum, then becomes 0, then again becomes maximum in the other direction, then again becomes 0. So if you take the average value over the whole cycle, each positive value will be cancelled by negative, so the average value you will get at 0 for the whole cycle. So what you will do is you will take the square so that the negative part get cancelled. Now physically you can say, if I say IRMS, then I can say IRMS actually means the current, AC current, which produces, you define something like this. IRMS is equal to the value of that particular DC current which produces the same heating effect which the AC current is now producing. So when you send an AC current to a resistor and you find out how much heat is generated and what should be the value of the DC current which should be sent through the same circuit to produce the same heating effect, that value of DC current is equal to IRMS. So that is what the actual definition is. So coming back to this, so for solving all these things you require only the equation. So VRMS is given by V0 by root 2. Similarly, IRMS is given by I0 by root 2. Now, if you compare both equations, you can see V0 is 200. So we have V0 by VRMS will be equal to 200 divided by root 2. Similarly, so we will discuss about IRMS later. Now let us find out what is frequency. So frequency, you know, at the omega is represented by 314. So omega is equal to 314. So what is actually omega? It is angular velocity. So omega can be written as 2 pi times the frequency. So 2 pi times the frequency is 314. So if will be equal to 314 by 2 pi. So pi you can write it as 3.14. So you will get 100 by 2. So you will get it as 50 Hertz. So the frequency of the given AC voltage is 50. Similarly, RMS value is 200 by root 2 volt. Now what is IRMS? So you have the peak voltage is V0, that is 200. Then you have the frequency, which is 50 Hertz. Then you have the RMS voltage 200 by root 2. Then you want to have the RMS current. See, this voltage is applied across a resistor. So VRMS by IRMS, since it is applied across a resistor, so you can find out IRMS equal to, as per the Ohm's law, VRMS by R. So it will be equal to 200 by root 2 divided by R. So in 110, so you will have 20 by root 2 amperes. So this is IRMS. So you have got VRMS and IRMS. Then one more part is that power dissipated. Since it is applied across a resistor, power is given by V times I, or VRMS times IRMS, or you can write it as VRMS, you can write it as IRMS times R times IRMS. So you can have I squared RMS multiplied by R. So you already got the IRMS, which is 20 by root 2 squared multiplied by R is 10. So 400 times 10 by root 2, that is the power representing watt. So once you get an equation, you should be able to compare it with the original equation or the actual equation. Then you can write it term by term, and if you know the relationship between the RMS and the peak value, then you can easily find out each term which they have asked. Normally such questions do come in board examinations, comparatively easy questions, but once a child sees the equation and all, he will get confused what to be substituted, where to be substituted. Now another question related to this RMS is normally they will ask why this AC voltage or AC current is more dangerous than the DC, a commonly seen question. So that is because, see, whenever we say it is 200, the domestic voltage supply is some 230 volt or 220 volt. So we actually mean it as VRMS. So VRMS is 230, or V0 by root 2 times is 230 volt, or V0 is root 2 times 230 volt, means the peak value of the voltage can reach up to root 2 times 230, some 311 volt something. So voltage can vary up to 311. What you are expecting is 230, but it can vary up to 311. But if you compare it with DC, if it is 5 volt, the maximum value it can reach is 5 volt. So you can't expect more than that. So that is why the AC is considered more dangerous compared to the DC.